For anyone that is still taking SATs and struggles with percentage problems, there's really only one method you need to learn in which you should never miss a percentage problem again. We call this the open method. So what the open method means really is just original times my percentage equals my new value. This is the only formula that you should need for percentage problems. There are a couple slight variations you should know as well. So if we're ever dealing with a percent increase, the only change in my formula, well, now it's original times 1 plus my percentage equals new. And if we're doing a percent decrease, we want to use original times 1 minus my percentage equals new. This first equation you really want to be using when you're just finding percent of some number, and it's not an increase or a decrease. So write those down if you don't have them already, and then we'll work through some problems that most students really struggle with. But if you use this method, all of these really should not be too bad. So let's look at this first problem here. See if we can apply the open method. So 432 is 96% of what number? Now this one we can just use the normal open method for because it's not an increase or a decrease. So let's see here. 432 is can always be our equal sign. So equals 432. Now they're saying we need to figure out what the number is before we decreased. So if it is 96% of what original number, then we don't know our original number yet, but if it's 96%, then we've gone down 4%. X times 0.96, it's the same thing. X times 0.96 equals 432. Then to get X, we just need to isolate it, times 0.96 on this side, divided by 0.96, and divided by 0.96. When you do that, 432 divided by 0.96 will get you to 450. So X in this case should just be 450. We can go here and check our answer. X is 450. Okay, let's look at our second problem. So in this one, it says the number n is increased by 6%. Well, if we're increasing by 6%, we know we want to use the formula original times 1 plus p equals my new value. So the number n, which should be our original number, is increased by 6%, and that result, what we get after, is 318. So we know it's going to end up equaling my new number, 318. So our original number, which we don't know, times 1 plus, what's our percentage? 6% in this case, so we can write that as 0.06. So original times 1.06 equals my new number, which is 318. So then how do I get to my original number? We just need to isolate again, so divided by 1.06 on both sides. So 318 divided by 1.06, and we should get our original number. In this case, original equals 300. So we started with 300, and after we increase by 6%, we end up with 318. Let's go back over here and check our answer, and it is, in fact, C, 300. Okay, let's look at our third problem. After 20% of the original number of marbles in a group were removed from the group, 360 marbles remained in the group. How many marbles were removed from the group? Okay, so another one here where we don't know our original number. So if we're going to be using the open formula, the O, the original, we don't know. But if 20% were removed, we know this is going to be a decrease. So we want to do 1 minus our percentage, in this case 1 minus 0.2, and that should equal whatever our new number is. So 360 is what we have after that decrease. So ends up being original times 0.8 equals 360. So to get back to where we were before we removed the marbles, we can just isolate our original number here, divided by 0.8 on both sides, and say 360 divided by 0.8, and you end up with 450. So I should have 450 as my answer for my original. I'll be very careful reading this problem though. Are they asking for how many marbles we had before we removed any? Is it 450? Well, in this case, they want to know how many marbles were removed from the group. So then we can just do 450 minus the 360 that were left over. 450 minus 360. That means we lost a net total of 90 marbles. That's what they're looking for. So our answer here should be B, and it is. Okay, On to the next problem. Okay, the result of increasing the quantity X by 400% is 60. So this is one a lot of students struggle with, and I see pretty much most kids miss this one, but if you set it up the same way, it really shouldn't make a difference. So in this case, we just have to pick what formula we're using. In this case, we know it's going to be a percent increase, so we should be working with original times 1 plus our percentage is going to be equal to our new value. If we know it's that formula, it's all about just plugging everything into the right spot. So the result of increasing the quantity X by 400% is 60, is we know is always equal to, so it is 60, that's going to be our result. The quantity X that's being increased, we don't know, that can be our original number. So original, we don't know. If we're increasing by 400%, it's not 400% of the original number, it's a 400% increase. So 1 plus that 400% increase, or 1 plus 4. So x times 5, or 5x, has to be equal to 60. So to find that original number, again, we're isolating for O, or for x in this case, all we have to do is divide out 5. So then 60 divided by 5 gives us 12. So x should have been 12. And let's double check over here and see if that's the right answer. The correct answer in this case is, in fact, A. So 12 is what we started with. When we increase that by 400%, so 1 plus 4 times our original, gets us to that value of 60. And remember, is always going to be equal to, so that's how we know that's what we're setting it equal to. Okay, let's look at the next problem. For each of these problems too, you should go ahead and pause the video, try and do it yourself. If you're just listening to me talk, it's not going to help as much, but if you pause the video, try it, and then come back, then it should give you a lot more practice. Okay, so for this next problem, it gives us that 140 is p% greater than 10. What then is the value of p? Well, we see that 140 is, we should always know that is means equal to, so is 140. So that means 10 must be our original value then. 10 is what we're starting with. And if it is an increase here, because it's percent greater than, then we want to do 1 plus p. And in this case, we don't know p. That's what we're looking for. So let's see if we can solve here. We want to get p by itself. So let's divide by 10 on both sides and say 1 plus p is equal to 14. Okay, so then how do we get p by itself? Subtract a 1 on both sides. P then equals 13. And this is, of course, in the form of the decimal. So if we want to find the actual percentage, we need to multiply this number by 100. So 13 times 100 gives us the percent that we actually increase, which would be 1300%. We didn't go up by 13%. And if you do get 13, and if you're unsure why that's not right, just think about, if I have 10 and I go up by 13%, should I really be at 140? So most people end up putting 100 or 1400 as their answer because they forget the 1 plus p. Because 140 is 1400% of 10, but they're not asking what percent is 140, they're asking what percent greater is it. So another way you could think about that is just say it's 130 greater, and then find the percentage of that. But either way, if you set it up with the 1 plus p in the open formula, you should get to your right answer, which in this case is 1300. Let's go over here to double check. Correct answer is B. Okay, 2 problems left. So for this one here, they say that the regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price. And the sale price is 30% greater than the store's cost for the shirt. What was the cost in dollars for the shirt? Okay, so we know that $11.70 is the regular price. To find the sale price, because we know that's 80% less, well, that's going to be a decrease, so we should be using the formula 1, or we start with our original, open, 1 minus p is equal to our new value. And let's think about what we know. Well, we're starting with 1170. We haven't done the decrease yet. And then 1 minus our percentage. So in this case, 1 minus 0.8 to get us to that sale price is equal to that new value. So that's the same as saying 1170 times 0.2. And if we do on our calculator, 1170 times 0.2, we end up with $2.34. So that's our new value. And now that we have that new value, which is the sale price, we have to do the next part of this equation. So if we know the sale price is $2.34, let's just write that somewhere. Sale price equals $2.34. Okay, they say the sales price is 30% greater than the store's cost. So if we kind of break down what that means the sales price is the sales price is going to be what we set it equal to. So we can say equals 2.34. And what is this sales price? It's whatever the storage cost is plus a 30% increase. So we can say now our original number can be our storage cost. And then that times 1 plus our percent increase, which we in this case we do know. We can just say times 0.3, which would be 30%. And now let's try and simplify that a little bit. So our original, what we paid for this shirt or the cost of it, times 1.3 gives us the sales price that they sell it at. So then how do I find that storage cost? I can just get the original by itself, divide by 1.3, divide by 1.3. And if we do 2.34 divided by 1.3, we should end up with the storage cost being $1.80. Let's go over here and check and see if that is the same when we do get 1.849/5. Remember, you can put fractions as an answer in the SAT, but it would have to be the most simplified form. Okay, and then for the last problem we have here today, this is one that most people I've given this problem to miss on the first try because of the wording or because they're not using the open formula. But if we're using the open formula, it shouldn't be too bad. So according to a set of standards, a certain type of substance can contain a maximum of 0.001% phosphorus by mass. If a sample of substance has a mass of 140 grams, what's the maximum mass in grams of phosphorus the sample can contain to meet these standards? Okay, let's try and break that down. So it says whatever the substance is can contain a maximum that percent of phosphorus by mass. So if we have 140 grams total, they want to know how much phosphorus can we have in that. Well, it's just going to be 0.001%. So we could do 140 times. But remember now, we don't want to plug in our percentage here. Just like if it was 50%, we wouldn't plug in 50, we'd plug in 0.5. So here we need to either divide by 100 or move this decimal twice to the left. So times 0.00001. So when we plug that in, 140 times 0.00001 should give me 0.0014. That should be the total amount of phosphorus available in that sample. We can check here, 0.0014. So a lot of students here would just get 0.14. So be very careful to not plug in your percentage. It's to plug in the decimal form of that by dividing by 100. So those are all the problems I have for you today. After today, if you run into any percentage problems, if you try to apply the open formula, whether that be the regular open formula or 1 plus or 1 minus, those should work for any and every problem you run into on the SAT. If you like this video, please leave a like. If you have any questions or other kinds of videos you want me to cover in the future, please let me know down below.